Off we go into the wild blue yonder, climbing high into the sun. Here they come. You know what, Hap, to be honest, I've been singing this since we started driving through Montana. We're here in Seattle now. I think I've paid my punishment. Let's get geeked up. We're here in Seattle, we're here at the University of Washington, and I'm positive we're gonna hear a latte of good ideas. Huh? All right, fine. You know what? Let's just get to the ideas.
My name is Joseph Brown.
I'm David Ginger.
David McCune.
My name is Greg Miller.
My name is Ximiao Zhang.
From the University of Hawaii at Manoa Mechanical Engineering Department.
I'm the Vice Dean of the College of Engineering at the University of Washington. I'm also a faculty member in Civil and Environmental Engineering.
I volunteer at a innovation hub in Tacoma, Washington called the Readiness Acceleration and Innovation Network.
I'm the Querim Professor of Chemistry and the Chief Scientist of the University of Washington Clean Energy Institute.
I'm from the Ohio State University. I'm with the Department of Electrical and Computer Engineering.
If you have an innovation that you imagine might apply in a system, it makes sense to have those innovations tested where the soldiers, sailors, and airmen are. And so if you have the combination of academics with the university, a makerspace, and a place to field test these innovations, it seems like the perfect place to bring innovations to the next step forward of testing them in the real world.
My big idea for TED is how can we bridge the divide between biological chemical computers and electronic computers. So all of our electronic computation is done with electrons in silicon circuits, yet I would argue that the most important computation that's being done is in brains with ion currents fired by neurons. So can we develop materials and device architectures that allow us to interface those two systems, either for robotics or artificial limb applications?
My big idea for TED is to shrink sensor packages down to the size of a cell, like a biological cell, and fit both the electronics and power supply and the multifunctional sensors into nanoscale structures that could fit within cells.
So Ted, my big idea is to think of aircraft that can disassociate and then reassemble themselves. Essentially, sort of a variation on this swarm idea, but you're still dealing with a monolithic vehicle that essentially explode itself to avoid whatever's coming and perhaps do things in pieces but then reassemble itself.
So what we're trying to do is to develop very high-speed data read paths by integrating all the issues and considering each truth from multiple layers to make it happen.
Walk over here, got coffee, look guys, I got coffee, I got donuts, we got black coffee for you, General Arnold, we got double espresso for you, Dr. Von Karman, and for me, the chocolate latte with extra whip. Don't judge me. Anyway, if you have thoughts on the ideas you heard, leave a comment down below. And if you have ideas of your own, head over to afresearchlab.com and tell us about it. Till next time, the three of us are going to enjoy our coffees. Oh no! Man down! Till next time, the three of us are headed out to the Texas A&M University out in College Station, and we can't wait to hear more of your awesome ideas. Right, Ted? Right, Ted? All right.